So for number 1, it's asking us the equation of the line passing through negative 3, 2 with gradient 2. So from here, we know the gradient and you know which point it will pass through. So using this formula, y minus y sub 1 equals m times x minus x sub 1, you now have all the values that you need, right? So m is equal to 2, right? And then y sub 1 is 2, and then x sub 1 is negative 3. So minus negative 3 makes it plus 3 over here. So therefore, simplifying this, changing this in the standard format for equation of line, this is your answer. Y is equal to 2x plus 8. Okay? And then for number 2, here, you have a line with gradient 3. And then cuts the x-axis at 4. Find its equation. When you see this phrase, cuts the x-axis at 4, that means on your y-axis, it will intersect um, that axis at 4, making your coordinates 0 and 4, right? X value is 0 when the point is on the y-axis. That's why the point here is 4, 0. All right, so we have everything that we need. So we have the gradient, we have a point, so we can substitute everything here in this formula. So doing so, our equation is y equals 3x minus 12. So simple as that. Okay, so those are the answers to your homework. Now, let me have some additional examples. Okay, now let me have example number 11. Uh, in this question, again, it involves the equation of the line. Okay, however, you're looking here for the coordinates of 2 points. Let me read the question. The line y is equal to 3x plus 6 passes through the point T3. Question, find the value of t. That's the first question. And then next, if the line meets the y-axis at point P and the x-axis at Q or point Q, find the coordinates of P and Q. So there are two questions in this example. The first question is, you're given the equation of the line, you're given a point, you need to find the value of t. That's your first question. Okay, so for that, this is my answer. So given the equation y equals 3x plus 6, you're given t3. So t is x, 3 is y. So substitute them both here. Okay, so that's why this is 3 equals 3t plus 6. And then solving for t is equal to negative 1, right? That's the first question. Now, second question. Now, if this line meets the the y-axis at point P and x-axis at Q, find the coordinates of P and Q. Now, again, just like what I've said from our homework, if your point is lying on the y-axis, x there is equal to 0, right? And then if your point is on the x-axis, the y value of that point is 0. So therefore, for point P, which is lying on the y-axis, its x value is 0, right? So from here, using the same equation of the line, right, because it's just the same line, x becomes 0. Therefore, giving your y value as 6, right? So therefore, point P is at 0, 6. And then for point Q, which is on the x-axis, its y value is 0. So therefore, using the same equation of the line, y becomes 0. So solving this, x will be equal to negative 2. All right, so therefore, point Q is at negative 2, 0. So these are the coordinates of P and Q. Okay, any question, class? All right, done. Okay, let's have one more set of examples. Now, in this last set of example about equation of a line, we are going to sketch these equations. Okay, and then I'll teach you how to sketch them faster. Okay, you don't have to create a table, designate values for x and y. No need for that. Okay, I'll teach you how to sketch these graphs faster. All right, so for letter A, so we're given y plus 2x equals 3. Now, if you're given an equation of line like this, I suggest that you transform them in this format. Y is equal to mx plus c. There's a reason behind this, and then I'll tell you why later. Okay, so that's what I did. I changed this into linear form, or yeah, this one. Y is equal to mx plus c. Now, what is your gradient here? Your gradient here is basically -2, right? And then your c here, or y-intercept, is 3. Okay. Now, let's draw our x and y plane. All right. Now, when you draw this, always begin, remember this class, always begin with your y-intercept. Always begin with your y-intercept. For example, your y-intercept in this question is 3, right? So let's plot 3. So let's say there is 3. Okay. So there is your first point. Now, what you need to do next is to locate your second point. And how are we going to find our next point? Now, for your next point, you need the gradient for that. Okay. So, okay, let me move this a bit here. Okay. All right. Okay. Now, what is your gradient? It's -2. It is -2. Basically, it is -2 over 1, right? Right? It's always over 1. All whole numbers, negatives, integers has a denominator each, which is 1. Okay. Now, the number on top tells you if your point is going up or down from your y-intercept. And then the number below tells you whether to go left or right. I call it rise and run. Okay, rise means that this number here on top tells you if it goes up or goes down. I think everyone knows that if it's positive, it goes up, right? And then when it's negative, it goes down, right? And then for the number below, it's run, because when you run, you go left and right, right? So the number here tells you whether you need to go left or right. Now, if you go right, that means it's positive. If you go left, that means it's negative. We are basing this from the x and y coordinates. Okay, so with that, okay, let's look for the other point. Okay, so this is our origin. Okay, this is where we are. This is where we are going to start. Okay, so here the number on top is -2. So we go up or do we go down 2 steps? It's -2, so we go down 2 steps, right? So let me add some numbers here. So this is 2, this is 1. Okay, so we go down 2 steps. 1, 2, right? It is the -2 here. All right. So okay, so we are currently right here, right? And then again, the number here tells you whether you need to go left or right. So since this is +1, that means we need to go 1 step to the right. Okay, so from here, you go 1 step to the right. That means, so jump there. Okay, so there you go. Okay, so that is your second point. Let me just remove this blue lines here. Okay, all right, so there you go. That's your second point. And then from there, you can draw your line. And then there you go. That's your line. And then don't forget to write the equation of the line. Y is equal to -2x plus 3. All right, so that's it. That's how you sketch this equation much faster. Any question, class? Again, let me repeat this part. Okay, I know this is the tricky part. Okay, now we use the gradient to locate our second point. Now we begin with our y-intercept, which is 3. Now again, the number on top tells you whether you go up or you go down. If it's positive, you go up. If it's negative, you go down. And then the number below tells you whether you go left or right. If it's positive, you go right. If it's negative, you go left. Okay, so from your y-intercept, you count 2 steps going down. 1, 2, right? So from here, and then your denominator is positive 1. So we go 1 step to the right. That's why we are now here. That's why your second point is over here. And then connect them, you have your line. Okay, simple as that. So any question, guys, for letter A? None? Now let's go to letter B. Now this technique here is very useful, guys, especially when you're doing exams. Okay, because as much as possible, you want to work faster and smarter. Okay, now let's go to letter B. So we're given here 3x minus 2y equals 1. Now again, this is not yet in this format, the standard line or equation of line format, right? So you need to rearrange this. So what I did here is to bring down negative 2y, transpose 3x to the right side. That's why I have negative 3x plus 1. And then, of course, it's always y equals mx plus c. So it should be only y. So I need to get rid of negative 2. Okay, so you need to divide both sides by negative 2. Okay, so therefore your answer here is y equals 3 over 2, right? It's not positive, and then minus 1 half. Okay, so this is now your standard form. Okay, and then this is what we need to find to plot our line. Okay, so again, always begin with your y-intercept. Okay, y-intercept is negative 1 half. Okay, so just to be sure, okay, draw it like this. Okay, so this is your y, this is your x axis. Okay, always begin with your y-intercept, which is negative 1 half. So where is negative 1 half? Okay, so let's say this is 1. So this is negative 0.5. So this is your first point location. Okay, and then from there, okay, so look at your gradient. It is 3 over 2. That means you need to go up 3 steps, okay, or 3 units up, and then the 2 here tells you that you need to go right 2 steps, right, or 2 units to the right. Okay, so let's do that. Okay, now before I do that, let me just add more units. Okay, so this is 0.5, this is 1, 1.5, this is 2, this is 2.5, this is 3. Okay, and then let's have 1 here, and then 2, and then 3. Now, the reason why I'm putting 0.5s is because your starting point is a 0.5. So maybe you'll end up with a 0.5 when you move your, I mean, when you locate your second point. Okay, so let's do that now. Again, this is our um, gradient. Okay, so again, the number on top tells you that you need to move 3 steps up. So from here, 1, 2, 3. So we are now at 2.5. And then how many steps to the right? So that is simply 1, right? So 1 unit here, and then 2. So your second point is here. It's over here. Let me use blue on this one. Okay. Okay. So again, 1, 2, 3. Okay, 3 steps up, and then 2 steps to the right. So from here, 1, 2. And there you go. So that is your line. Okay. Okay. So there you go. That is your 9. So that is y equals 3 over 2x minus 1 half. Okay, any question, class, on how to sketch these equations? Okay, no question? Okay, so my answer is 11 over 2. Okay, how did I get 11 over 2? Now, first, let me read the question. If the line through the point A is negative 2, 3 with gradient 1 half, also passes through the point 3k, find the value of k. So first, you need to find the equation of the line using this formula. Okay, so y minus y sub 1 equals m times x minus x sub 1. So m is 1 half from here. And then x sub 1 and y sub 1 are negative 2 and 3. Okay, that's how I got this. And then changing this to the format of y equals mx plus c. So you need to transpose 3 to the right side, simplify this, and you'll end up with y equals 1 half x plus 4. All right, plus 4. And then using this equation, you need to find for the value of k. So using the equation and then substituting those x and y values, you'll find that k is equal to 11 over 2. All right. So any question to ask for number 9? It's fairly simple, right? Okay. Now the next question is um, actually this is the second question. I just want to discuss this one first. All right. And then for the question on number 5b, how would you sketch this graph? All right. So this is my answer. Okay. For letter B. Now, for letter B, the question is 2y equals 3x plus 6. And then everyone knows that you need to change this first in this format. Y is equal to mx plus c. So what you need to do is to get rid of this 2 by dividing both sides by 2. By doing so, 2 gets cancelled, and then 3 becomes 3 over 2, right? And then 6 over 2 is what? 3. So therefore, this is the equation. So how do we sketch this again? Always begin with your y-intercept. Your y-intercept is 3. That's why your first point is over here. And then how do we go to the second point? You use your gradient for that. Now your numerator is positive 3. That means we go up 3 steps, right? And then your denominator is positive 2. That means we go right 2 steps. So from here, 3 steps up, 1, 2, 3, and then 2 steps to the right, so 1 and then 2. So you'll end up here, and then connect those 2 points, and there's your line. Okay, so that's it. That's it for number 5, letter B. Are there any questions, class, for number 5B or even number 9? Okay, none? All right, now let's go to the next topic.
Teacher,
Okay, yes, Sam.
what's the answer for number 9?
My answer is 11 over 2. Okay. I suggest that you just write your answer as fraction.
Yes.
So, okay.
Okay, thank you.
Don't need, yeah. All right. Now, let's go to the next topic. Now, so again, we've learned um, distance formula. We've learned midpoint. We've learned gradient, and then we've learned equation of a line. Now, the succeeding topics are new for you guys. All right. These are distinct for additional maths. Okay, so let's go with 7.5. Now, how do we find the equations of parallel and non-parallel lines? Let's first review what is the definition of parallel lines. When lines are parallel, well, visually they look like this. Okay, so these two lines here are parallel to each other. That means even you extend this as long as possible, they won't even intersect at one point. That's the definition of parallel lines. Okay, so their distance to each other is even if you extend these two lines. That's the definition of parallel lines. Two lines that will never ever meet, right? Okay, it's a sad love story, but good thing it's not. Okay, so parallel lines never intersect. And then, of course, non-parallel lines intersect at one point. Now, let's go first with parallel lines, right? Now, what, um, okay, now with parallel lines, how do we define parallel lines when it comes to gradient and then the equation of the line? There's just one distinct um, property that two parallel lines have with their gradients. Now, when you have two lines that are parallel, their gradients are always equal. All right. Again, their gradients are always equal when two lines are parallel. Remember that. Okay. So the set the next set of questions are about that. Okay. So let's have this one. Okay. Example number 13. Now find the equation of the line passing through the point A, 2, 1, and parallel to the line y equals 2x plus 5. Now, again, class, when we're looking for the equation of the line, what do we need? We need the gradient, and then we need at least 1 point on the line, right? That's what we need. However, in this question here, we only have the point, but we don't have the gradient. What it gave us is the equation of another line parallel to this line. Okay, there are two lines. So we have the first line, and then it gave you another line which is parallel to the first line indicated in the question. Okay, and then the equation of the line parallel to the question is y equals 2x plus 5. All right, so you have two lines. Okay, so the first line, you only know that point A is here. Okay, but you don't know the equation. All right, so since these two lines are parallel, that means that their gradients are also the same. Okay, again, whenever you see the word parallel to the line, means their gradient are the same. So therefore, from here, we already know the gradient of our line or our first line. Okay, so the gradient of our first line is also equal to 2 from here. Okay, so from there, we know what to do with this. So using the same formula, so m is now 2 here, and then x of 1 and y sub 1 are 2 and 1 respectively. So substituting all the values that you got, you'll end up with y equals 2x minus 3. All right, so that's your answer for this example. Any question, class? Again, when two lines are parallel, their gradients are the same. So if the gradient of line 2 is 2, that means the gradient of line 1 is also 2. Okay, if the lines are parallel to each other. Okay, let's have another example. Okay, number 14. Find the equation of the line which passes through the point A 2, 1 and it is parallel to the line 2x plus 3y equals 5. So how are we going to do this? So again, you have two lines. Now the second line or the second line's equation is given, which is 2x plus 3y equals 5. Now, in order for you to get the equation of the line, again, you need the gradient and one line. Okay, so you have your point, sorry, one line, 1 point. So you have your point here. Okay, you have your point here. So what do we need to find? We need to find for the gradient, and then the gradient can be found by rearranging the second equation. Okay, so with that, I'm going to rearrange this. So 2x plus 3y equals 5. So rearranging this in y equals mx plus c format. So we bring down 3y, transpose 2x becomes minus 2x, and then plus 5. Now it should only be y, so I need to get rid of 3. So you divide this side by 3, also this side by 3, cancel 3, y is equal to negative 2 thirds y plus 5 over 3. Okay, so what is the gradient now from this equation? So the gradient is negative 2 thirds. Okay, so from there, you can now find your equation of the line, okay, of your outer line. Okay, so the equation of the line is y minus y sub 1 equals m times x minus x sub 1. All right, so y minus, what's the point? It's 2, 1. So y, so this is 1 equals m is negative 2 thirds, and then x, so minus 2. There you go. All right, and then what do we need to do? We need to again change this in this format. Y is equal to mx plus c. So I need to transpose negative 1. So bring down y, and then you need to distribute this. So negative 2 thirds x plus 4 over 3 plus 1. Okay, so your final answer is this. So negative 2 thirds x plus 7 over 3. So this is your answer. All right. Any question, class? Okay, none. So basically, that's how you solve for, or that's how you look for equations of two parallel lines. Again, their gradients are the same. Now, what if they're basically non-parallel lines? So non-parallel lines will always intersect, okay, at least one point. All right, so how do we solve um, um, non-parallel lines? Okay, so basically you have learned how to do this back in chapter 2. So when you have two lines, actually this was learned when you were in sec 2. These are simultaneous equations. All right. So when you have two lines that are not parallel, you just need to solve them by um, making them equal to each other, right? Or by any simultaneous equation technique that you still remember. Okay. So there you go. Okay. So for example number 15, take note, this is my last example for today. I only have one example for this because you already have learned this. Okay, so how do you find for the coordinates of the point of intersection of the lines y equals 3x plus 4 and then 3x plus y equals 10? Now you can only solve this by solving them simultaneously. So either by elimination or substitution. For me, I'll just use substitution because you can clearly see from here that you can substitute this for y, right? Because y equals 3x plus 4. So this y here is equal to this, right? So from there, y equals, sorry, I'll just solve this straight away. So 3x plus y equals 10. Now by substitution method, I'm going to substitute the equation of y. So this one, 3x plus 4. So plus 3x plus 4 and then equals 10. And then that's how you solve for x and y. You already know this, guys. So bring down 3x plus, okay, let me just answer it right away. So 6x equals, so 10 minus 4 is 6. So therefore x is equal to 1. right? And then how about for your y value? So just use that one. So 3x plus 4. So y is equal to 3 times 1 plus 4. So your y is equal to 1 and 7. And that's it. Okay. So any question, class? Any question with this one? All right. So that's it for parallel and non-parallel